Hello students. So in chapter 12 we're going to talk about pediatric dosages. So I encourage you to read pages 334 to 336 for important information about administering medications to children. And we will go over some examples from the book in this video and in the next video. Okay, so pediatric drug dosages are usually based on the child's weight. Okay, and in certain applications, drug dosages for children can be based on their body surface area. Okay, especially in pediatric oncology and critical care. So you can read more information on your own. Okay, so we're going to talk about oral medications. All right, so oral medications and dosages based on the child's body size. So we're going to look at example 12.2. And the problem says the prescriber ordered the drug 19 milligrams per kilogram by mouth, oral suspension every 8 hours for a child who weighs 50 kilograms and has otitis media. All right, and we're going to read the label in figure 12.4 and calculate the number of milliliters of the antibiotic the child will receive. Okay, so before we look at the figure in the book, right, we're going to go ahead and take the patient's weight in kilograms. All right, and multiply by the 19 milligrams per kilogram. Okay, so multiply by 19 milligrams per kilogram. Okay, let's go and put that in our calculator. So 50 multiplied by 19. Okay, it's 950. Okay, so the patient will receive 950 milligrams of the medication. Okay, so we need to look at the label in figure 12.4 and calculate the number of milliliters that will be given to the patients. Okay, so what we're looking for is the strength of the drug. Right, so how many milligrams are in a milliliter? Okay, so according to the label here, the strength here is 250 milligrams per 5 milliliters. Okay, so what we're going to do is take the 950 and multiply it by the reverse of the strength. So we're going to put the 5 milliliters in the numerator of the fraction. Okay, so 5 milliliters up here. And then the 250 milliliters, or milligrams in the denominator. Okay, so we're going to take 950, multiply by 5, and then divide by 250. Okay, so we get exactly 19 milliliters, right? So we would administer 19 milliliters to the patient. Okay, so that completes the first example. Okay, and you can look at the solution in the book, so that appears to be what the book is getting as well. Okay, let's go to look at the next example, 12.3. And the problem says the prescriber ordered Zithromax, okay, also known as azithromycin, 10 milligrams per kilogram by mouth immediately. Okay, then give 5 milligrams per kilogram per day for 4 days. Okay, and it says the child weighs 18 kilograms. Read the information on the label in figure 12.5 and determine the number of milliliters that would contain the stat dose, right? So the dose to be given immediately. Okay, so we're going to take the child's weight, which is 18 kilograms. Okay, and then multiply by the 10 milligrams per kilogram. Okay, so 18 times 10. Okay, feel free to do a quick mental calculation and then double check with your calculator. So 18 times 10 is 180. Okay, so it's 180 milligrams. All right, so now we need to look at the label to figure out the concentration of the drug. Okay, and it says 200 milligrams are in 5 milliliters. Okay, so we're going to flip that around. Okay, so take the 180 milligrams. Okay, and multiply by. Okay, 5 milliliters over 200 milligrams. Okay, so we're going to do 18 times 5, and then divide that, or 180 times 5, and then divide that by 200. Okay, we get 4.5. So 4.5 milliliters will be given to the patients. Okay. All right, so next we're going to do one example of a dosage that's based on the patient's body surface area. Okay, so we'll go ahead and do example 12.6. Okay, so we have an order for this drug. Okay, 10 milligrams per meter squared, okay, by mouth every 6 hours. Okay, until the serum methotrexate level, okay, hopefully I said that correctly. So the serum methotrexate level is less than 10 to the negative 8 m. Okay, so whatever that means. Okay, so the strength of these tablets are 5 milligrams. So in other words, each tablet contains 5 milligrams of the drug. So we're going to calculate the number of tablets that contain the dose for the child who is 85 centimeters tall and who weighs 12 kilograms. Okay, so as you can see, the patient's measurements are given in metric units. So the patient's height is given in centimeters, and then their weight in kilograms. Okay, so before we calculate the amount of the dose that we're going to be giving to the patient, okay, we need to choose the appropriate formula to get the BSA. Okay, so there are two BSA formulas that were used in Chapter 6, so you can look them up in Chapter 6. Okay, so we're going to use the one that that allows us to plug in the child's measurements, okay, their weight and height in kilograms and centimeters. So we're going to use that first formula here to get the BSA. Okay, so the BSA is equal to, okay, the square root of, okay, the child's weight in kilograms, which is 12, so that goes in the numeration 12 kg. Okay, multiplied by, okay, so multiplied by their weight, or I'm sorry, their height in centimeters, which is 85 centimeters. Okay, and then divide that by 3,600. Okay, so we're gonna do the part inside the square root first. So 12 times 85 divided by 3,600. Okay, and then once we get that number, do not round it. We're going to take the square root of that exact decimal, okay, without rounding it. So the square root of our previous answer. Okay, so then hit enter. Okay, and we're going to round that to 2 decimal places, so we get 0.53 meters squared. Okay, is the body surface area. Okay, then we're going to take that body surface area, okay, and then multiply by the 10 milligram per meter squared. Okay, so 0.53 times 10. Okay, you can probably do a quick mental calculation, but let's put it in the calculator to double check there. So we get 5.3 milligrams. Okay, so that's the amount of the dose. So now we're going to figure out how many tablets to give to the patient. And it says that the strength of each tablet is 5 milligrams. So that means one tablet is equal to 5 milligrams. Okay, so we're going to take our 5.3 milligrams. Okay, and multiply by 1 tab over 5 milligrams. So essentially we're going to divide the amount of the dose, okay, by 5 milligrams to figure out how many tablets. Okay, and this should seem pretty straightforward. Okay, so 5.3 divided by 5 gives the number of tablets. Okay, obviously it's not going to be a whole number of tablets, right, because the amount of the dose is not a multiple of 5. Okay, 5.3 is not a multiple of 5, so we're going to get a decimal. Okay, now obviously we can't give 1.60 tablets. Okay, that just isn't possible. Okay, so we're not going to assume that we're going to be able to give 1.6 tablets. So what we're going to do is round that down, or round it to the nearest whole number here. Okay, so we would give 1 tablet to the patient to administer the dose. So the answer would be 1 tablet. Okay, so that completes the examples for this video. In the next video, we'll continue doing more examples from Chapter 12. Thank you for watching.